Okay, the recording should be started. So welcome to the Manhattan GMAT Study Hall for April 12th, 2012. And today's topic is the third installment of our Inequalities workshop, which will touch on a couple other things as well, number properties and so on, and some other aspects of inequalities that were not touched on in our original inequality workshops. So, before we start, we have to open with the same rules that you guys are probably used to seeing by now. So let's look at those. The usual warnings we have to give you. First, as far as problem submissions, they shouldn't be too general. Basically, you can't ask about the entire test all at once. So, or huge, vast subject areas like geometry, which is too much for a single session, or how do I do problems faster across the board. Too much. I mean, we have to keep to a reasonable scope here. But on the other side, and more importantly, make sure you don't submit problems that are too specific. So, this is the big thing that people are doing in the submissions that's not so great, is they're submitting single problems that are not tied into larger areas. And remember, that's why we have a forum. That's the purpose of the Manhattan GMAT forums, is to address single problems and specific questions about those single problems. So you should use the forums for that. Finally, no personal study plans. These recordings usually have between 30 and 40 live attendees, but they're watched by hundreds and sometimes thousands of people. So if you submit a personal study plan, it's not really going to make sense for us to talk about that. So we do have a place for that on the forums. We have a folder entitled General Questions, and that's the folder where you can submit all those things that have to do with personal study plans and so on. As far as what we should see topics of intermediate depth. When we say intermediate depth, we mean not so general as to be all of the test or a huge swath of it, but not so specific that it's a single problem. So one thing we did earlier was the median in statistics. That should give you the right idea of how broad these things should be. Also, if you're going to ask specific problems, that's best. It's actually good if you give us examples, because a lot of the time people will submit topics and we don't really know what they're talking about. So if you give us a specific problem, that's best, but just make sure that you do tie it into a general question like the type that we're talking about here. So if you just give us a problem, then we will expect you to post it on the forum. But if you tie it into a more general question, then we can possibly use it here. Also, you've got to cite the source, and last but not least, we are not allowed to use problems from the official guide, because GMAC has explicitly asked us not to use problems from the official guide, and so we need to comply with that mandate. So those are the usual warnings. Just a couple of reminders of the little violations, the little infractions that people commit the most often here. First, official guide problems, don't submit them. People like to do it, don't do it. Also, please don't submit single questions with no larger context. Put those on the forum. Finally, this may be a language barrier issue, but remember, the ultimate goal of all of this is to become a business person in the United States. And a big part of that is the undertones behind language and what constitutes professionalism and politeness versus rudeness and all that other kind of stuff. And if you submit your question in a way that comes across as rude, even if that's not the intention, that's not a good thing. So, you wouldn't want to say that you expect us to do this, or that we should do this, or anything like that. Even if it's not on purpose, it's important that you learn those kinds of rules of etiquette so that you can eventually use them in your own career. So there's those. Okay, other things. The other thing we tell you before every class, please check the archives. This is another very big deal. A lot of people have been submitting topics that are actually identical to things that are already in the archives. So, like literally the same. So please don't, unless you differentiate the topic in some way. Like the reason we're doing inequalities again today is that people have submitted inequalities in ways that differ in some sort of substantial respect from our previous treatment of inequalities. But if we just said, hi, can we cover inequalities, the response would be we already have. So if you're going to submit previously covered topics, please differentiate those in some way. Like here's an aspect we haven't covered yet, or here's a way that we haven't treated this topic yet. Those are the rules. If you understand those, please go ahead and click the smiley face icon, which is over there to your left. Smiley face icon. Okay, I see a few smiley faces. All right, good stuff. So let's go ahead and get started. Again, remember today's topic is Inequalities Workshop, Part 3. So let's do it. One other reminder, there's answer buttons. You shouldn't see those yet, but you're about to. So here are the answer buttons. They should have just appeared to your upper left of your screen. You should see these under the list of names. You should see A, B, C, D, and E buttons. And when you pick responses, they will not be visible to the other students in the class. So, yeah, a couple of you have put A already. Please don't answer just yet, but you should see these buttons. When we do multiple choice problems on the screen or data sufficiency problems, which are also basically multiple choice, please answer those problems using these answer buttons. Please do not answer in the chat box because we want to make sure everybody has the same fair shot at solving the problems. And if you're spitting out answers into the chat box, that may have an undue influence on other people's thought process. So please try to make sure you don't do that. All right, smiley face if you see the answer buttons in your box or below your box. Smiley face, there's the answer buttons. Okay, let's go ahead and get started. Let's look at some problems on inequalities. So all of the problems are from the GMAT prep software with the exception of one problem. So we'll see that one a little bit later in the session. But there is one problem that I made myself. The rest of the problems are all from GMAT prep. So here's the first one. Remember when you do these things, please use the answer buttons and we'll get going. Before we start this one, let's have a quick discussion of time. So it's a little bit ironic that we're discussing timing and we're going to leave the problem up on the board while we discuss that. But let's discuss that topic real quick. How long should this problem take? Does anybody know? In the text box, if you have an opinion on this, go ahead and put it in the chat box. How long do you think a problem like this deserves? Minutes, seconds, that kind of thing. Okay, so some people are saying anywhere from 2.5 minutes to about 30 seconds. What we're really looking for is something like this. Something like this that will show up momentarily. What we are really looking for is something like what this person wrote. And the general principle here is that the problem is short. So 2 minutes is an average time. That's the thing you've got to keep in mind. That's an average. Remember the way that averages work. Sometimes you're going to be above the average. Sometimes you're going to be below it. But 2 minutes is an average. It's not a limit. So make sure you don't treat it as a limit. So shorter problems should be less than 2 minutes. Longer problems should be more. Or longer problems at least deserve more time. This doesn't mean you have to take up that much time, but when you see a problem like this, there are no words, there's nothing to decode. The entire problem is basically right there in front of your face. So when you see a problem that's like this, your first thought should be, okay, this is not going to take me the average amount of time. It's going to take me less. So with that in mind, let's do about a minute 15 or a minute and a half for this problem, maybe a minute 20 or so because it's already been up on the board for a while. So go for it. Remember to use those answer buttons. This is a data sufficiency problem, by the way, so if any of you are very, very new to this exam, you might not know how that works, but if you don't know the data sufficiency answer choices, then make sure you check out our publications, our introduction books where we discuss that stuff. Go for it. Okay, it looks as though I'm having some connection problems, but let's see what we can do. Okay. Yeah, you know what's interesting about connection problems in Silicon Valley? First of all, make sure you can you guys all hear me okay? Give me the smiley face icon if you guys can actually hear me. Okay, and if there's no interruptions or anything like that in the audio. Okay, excellent. Yeah, it's funny because I've actually had a lot more issues with connections here than in many other parts of the world that are not as well known for their technical prowess, but it's another story. So anyway, let's take a look at this problem. Is x plus y less than 1? And we have two choices that involve fractions. So first of all, let's have a baseline discussion of yes-no questions in data sufficiency. Let's make sure we know how to approach those. Does anybody in the chat box have a general approach for these kinds of things? Yes-no questions. Does anybody have any sort of general thoughts on how to approach such things? Yeah, I like what Jay is saying here. Try to prove insufficient. Kurt's point is also a valid point. There are two types of sufficient on these. Although if you know what Kurt is talking about, that's actually sort of a minor point. That's not really something that's going to come up very often. What I was going at here is what Jay is saying, which is this. Your goal on yes-no questions should be to see whether you can get both answers, yes and no. In other words, you're trying to prove insufficient, and only if you can't get that to happen would you concede that it's sufficient. So let's take a look here. Well, can we get a yes here? Well, let's look at statement 1. Individual statements, you can get rid of those pretty quickly here. Statement 1, y can be anything, so we can get yes and no. Same sort of thing with statement 2. Same observation works, except it's the other way around. X can be anything, so we can also get yes and no. So in terms of our grid that we make when we do these problems, A, D, B, C, E, we can relatively quickly get rid of A, D, and B. Now, the two statements together, let's try to get a yes and also try to get a no. See if we can do that. So can we get a yes to this question? Sure, that's pretty easy. I mean, most random values you pick are going to give you a yes here. For instance, you can just pick 0 and 0. So 0 plus 0 is less than 1, and that's going to be a yes. So the real issue here, remember what we're trying to do. We're trying to get yes answer and no answer. So can we get a no? What do you guys think in the chat box? By the way, here are your statistics. With the connection trouble I'm having, it might take a while for the statistics graphic to load, but here are the stats. So we have some people who think you can get a no, and we have some people who think you can't. So in the chat box, let's discuss. Can we get a no to this question? Yeah, Rajul, where are you getting those numbers? Like, what is 0.8887? It's numbers that are very, very close to the extreme values. So we have touched on this point in the previous inequality workshops, but it's definitely worth touching on again. One of the best ways to approach inequalities is to plug in extreme values of the variable or variables in question. Because, I mean, this is true with real life inequalities as well. Like anything that's an inequality in real life. Like if you want to know whether a bungee cord will hold people from 100 to 300 pounds, you would try a 100-pound person and you would try a 300-pound person. Those would be the first two you would probably try. So plug in extremes. So how big can these numbers get? Well, you're trying to make this more than 1, or at least you're trying to make it 1 or more. So how big can the numbers get? Well, x can be anything less than 8/9, which Rajul expands as a decimal. You don't have to expand it as a decimal if you'd rather think about fractions, but it's nice to think about this in different ways. Similarly, y can be anything at all less than 1/8, which is 0.125. And so that's where we get this from. This is a choice of extremes that one of the students here chose. And it's good enough to give a no answer to this question. So this is greater than 1. So that's a no. So two statements together, you've still got yourself a yes, and you've still got yourself a no. So we are looking at E. So the value that you should get out of this, the takeaway that you should get, is the importance of considering extreme values when you think about inequalities. Especially if you are confused by an inequality question. That makes it even more important to think about extreme cases and see what the deal is with those extreme cases. So any questions about this, go ahead and spit those out. Otherwise, we will move on to a problem that I wrote, which is the only problem in today's slides that's not from GMAT Prep. Any questions? Okay. So here's, by the way, Sarah, the program says that you're away. I think you clicked on that door icon, so you should unclick that. Not the hand icon, the door icon. There you go. Okay. The question is this. These are a little hard to come up with during the test. No. Well, not necessarily, right? If you came up with numbers like that completely at random, then they would be hard to come up with. But what's the genesis of these numbers? Like, these are numbers that are close to the maximum. These are numbers that are extreme. Because remember what your limits are in the problem. Your limits in the problem are 0.88888888 is a ceiling on x, and 0.125 is a ceiling on y. So that actually makes numbers like this. If you know that your job is to pick extremes, then that makes these numbers relatively straightforward to pick. Because this is a number that's just ever so slightly less than that. And 0.124 is ever so slightly less than that. So there you go. Satish, yes, although there are problems in which that will get you in trouble, like in which just combining the inequalities will maybe lead you to a wrong conclusion. If I had a second, I can make up a problem where that's the case. Okay, but the takeaway we should get here is extreme values. These are not random choices of numbers. These are numbers that are the extremes in the problem. If no one else has any other queries, let's go ahead and, yeah, you can add them, but insufficiency, that can cause some issues, which I can make a problem that does that. In fact, let me think about how to do that in a second. But in the meantime, let's try another one. Okay, here's a problem. Go for it. Made by me. This is the only problem in today's slides. It's not from GMAT Prep. Here's a timer. Okay, let's pick answers here, please. Remember, this is the GMAT. The GMAT is a test on which you have to pick something. So even if you have to guess, please pick something. Okay, here are your class statistics. There are quite a few people who seem to be marked away at the moment, so hence the glut of non-answers there at the bottom. But we have some opinions here, most of which are A and E. Let's go ahead and take a look. So if P, Q, and R are integers, is P plus Q plus R greater than 0? Is the question. So again, notice this question is yes, no. When you get a yes-no question, you have the job description that we talked about in the last problem. When you have a yes-no question, you should try to get a yes, and you should try to get a no. So with statement 1, let's take a look. P plus R has to equal Q. So can we get a yes? Well, how would we get a yes here? We could just pick 3 numbers that are what? Chat box, if you guys have ideas. Yeah, you could just pick random numbers that are positive. So that works. Because remember, to get a yes, you just have to make this sum positive. So just pick 3 positive numbers, as long as they conform to that equation. So for example, P equals 3, Q equals 2, R equals 2, and Q equals 5. That's a yes. Can we get a no? Well, how do we get a no? I mean, there's a couple ways that we can do that that are pretty straightforward. One way is just to pick 0, 0, and 0, which we are allowed to do per the problem statement because 0, 0, and 0 are integers. So if you do that, then you get a no. Or pick a bunch of negatives, like P equals -3, R equals -2, and Q equals -5. So statement 1 is insufficient. That gives us in our grid here, let's make the grid A, D, B, C, E. We got rid of A, D. Statement 2 we should be able to kill pretty quickly because statement 2 doesn't tell us anything about P at all. So remember, in terms of our goal of getting a yes and getting a no, statement 2, we don't know anything whatsoever about P. So you could, no matter what R and Q are, like you could make P big enough to make the whole thing positive. It could be big enough to overwhelm Q and R, in which case the sum would be positive. Or it could be negative enough to have the opposite effect. It could be big and negative and could have the opposite effect. It could overwhelm R and Q in the negative way, in which case the sum would be negative. So that's not sufficient. So we are gone with B too. So let's move to the next page and look at the 2 statements together. So let's put that in the back. Okay, so we're trying to get a yes and trying to get a no. 2 statements together. Does anybody have any idea what is going on with these? Like, how are you going to combine these statements? They look sort of interesting. Yes, we've got some ideas there. In fact, a couple people have some very good ideas here. So from statement 2, Q has to be negative. Let's go there first. So statement 2 is kind of a weird statement. But when you see a square, and this is like the main benefit of having experience with solving these problems, is you can be, oh, hey, I remember that kind of dirty trick from last time. When you see a square in there, one of the things that you should think about squares is that they are non-negative. So r squared is 0 or greater. And negative q is even bigger than that. So what this means that negative q is positive, which in turn means that q is negative. So that's really, I mean, you can get some conclusions about the relative magnitudes of Q and R from statement 2, but the most important thing about statement 2 is the fact that Q is a negative value. We don't know anything about the sign of R from statement 2 because positive and negative numbers get squared the same way. So the takeaway that we should get here is that many, many inequalities are disguised statements about signs. And so the actionable takeaway that you should get from that is that you should think about signs if you are at a loss as to how to interpret an inequality. Like if you see an inequality and just don't know what to do with it, then try thinking about signs. I mean, that won't necessarily get you everywhere that you need to get. And then the last problem, for example, that's not going to really get you places. But here it will. So Q is a negative number. Now, what do we do with statement 1? Well, there's a few places you can go with this. Let's just take what the statement actually says before we start thinking about doing fancy algebra stuff. The statement says that P plus R is the same thing as Q. So this is like a substitution, or it's basically saying these two things are the same. According to this statement, P plus R is exactly the same as Q. So what that means, since we've discovered that Q is negative, that means that P plus R is also negative. So this is negative, and this is also negative. But let's take a look at our original question. The original question is the sum of P plus Q plus R. Well, if you look at this carefully enough, you'll notice that that's just the sum of the purple thing and Q. And so we already know that that's some negative number plus another negative number. In fact, it's two of the same negative number added together. So that's a no answer to this question. A no answer is sufficient. It's just as sufficient as a yes answer. It's still an answer to the problem. So this is definitely a negative quantity. So there's other ways to do it. A couple of you have mentioned some that we'll see in a second. But first, let's get a takeaway from this. Let's learn something from this. Well, one thing you can learn here, among other things, is that you need to keep your eye on the ball. In other words, you need to stay focused on the actual question that you're dealing with. So, because there's a lot of places you could go with this, and there's a lot of algebra that you could do from here, but a lot of that would turn out to be unnecessary if you realize that what you're trying to do is just consider P plus Q plus R. So it's basically playing heads up. Like, oh, there's P plus R and there's Q. I could do things here, but in terms of that question, I don't have to do anything else. So perhaps the most important thing you can learn here is stay focused on the actual question. I'll fix the typo in a second. Stay focused on the actual question. Like, don't collect any more information than you actually need. Very important, because there's a lot of data sufficiency problems where you can just fall off a cliff if you start finding things that you don't have to find. So, questions about this particular method of solving? Okay, no one in the chat box. Let's take a look at something that one other student here said, which was substitution. So still discussing the two statements together. You can also substitute one of these expressions into the other one, still using the fact that Q is negative. So let's substitute. Well, let's go ahead and isolate for one of these variables. One student above said isolate R, so why not, right? When you do a substitution, you just have to pick something and then go for it. So that's an approach. So let's try isolating R and see what happens. If you isolate R from statement 1, P plus R equals Q, which means that R is Q minus P. So then what we can do is we can take that and plug it back into the question. Remembering to keep it as a question. When you plug back into the question, don't lose the question mark. When you manipulate the question, make sure that it stays a question. In other words, don't lose the question mark or other markings of the question. So it is P plus Q plus R greater than 0. Once we have this kind of substitution, we can take out R and we can put that in. So is P plus Q minus P greater than 0? In that expression, the P's are going to go away. Is 2Q greater than 0? So this is a no, and that's sufficient. So that's one way to do things. I mean, there are many, many, many other ways of doing things as well. But the point is, even if you might not have had a fully formulated reason for doing this, you should just jump on it and try it. You know, don't sit there and wonder whether it will work to isolate this variable. Just do it and see what happens. So basically, shoot first, ask questions later. Like, just try it. There may even be people in this very audience who thought about trying that and then just shied away from trying it. If that's you, make sure that doesn't happen. Any questions about this problem? Go ahead and ask in the chat box. So overall, this is going to be C, because the two statements together are sufficient. So C. If you have any questions, go ahead and throw those in the text box. If not, we will move on to something else. Say they typing. No one is typing. Okay, let's try another one. This one's got more words. Remember what we said about timing? It's basically the length of the problem. The longer the problem is, the more time you can reasonably put into it as far as ROI. So there's more words in this problem, so you can allot more time accordingly. So put a timer with a little bit more time on it for you. There you go. Okay, there are a lot of people not picking things here. So you gotta pick something. Remember, it's the GMAT. AK, don't answer in the text box, please. That's why there's this big picture on the screen with a giant circle around the things that you should use. Thank you. All right, everybody please pick an answer. Also, only click once. If you click twice, it'll unclick the second time. So, Team Money, right now you don't have an answer on the screen. Karen, you don't have an answer on the screen. Prabhakar, you don't have one. And, okay. So, let's take a look. Kind of all over the place with the class statistics. Not really a clear consensus happening here. Let's take a look. So, well, first, as with all other data sufficiencies, the first thing we have to do is focus on the issue. Like, what's the question? The question is, how many hardcovers? So this is not a yes-no type question. This problem actually requires a specific value. So for this number. So if you can get one value only, that's sufficient. And if you have two or more values, then that's not sufficient. So that's what we're after here. Ground rules, we're trying to see if we can get one value only versus two or more values. So, and then let's take a look. The paperback books are $8 a piece. The hardcover books are $25 each. And Juan bought more than 10 paperback books. Since this is a word problem, it also helps to organize it. So, let's just see what's going on. Well, for each type of book, we have the number of books, we have the cost per book, so that's total cost. And then we have hardcover books, and we have paperback books. And then remember, we should make the chart twice because there are two statements. So let's make the chart twice, not right on top of each other. And let's organize. So in statement 1, we know that these are $25 and $8. And then we also know that in statement 2. So we can put that in there right now. And then the total number of books we know for paperback is greater than 10. So at least we can put that in there, and we know that this is more than 80. And here's the key here. What's the minimum possible value here? Anybody know? Yeah, it's actually 88. So there's a big, big difference between this problem and something like this problem. In this number, you can be in this equation, this inequality here, you can be absolutely anything in the world right up to 8/9. You can't be 8/9, but you can be 8/9 minus like 1/1,000,000,000,000. Whereas in this problem, you can't be 80.00001. What's the difference? Like, why is it so different this time? You may want to tell me in the text box. There's a major difference here which effectively changes the entire game. Why do we need multiples of 8? Because the number of books has to be a whole number. So in other words, you can't just do algebra anymore. Like when you have whole numbers, the first thing is that the extremes may not be as close to the limits. For example, 88 is not that close to 80. But more importantly, you can't just do algebra. You actually have to spell out the cases. So when you have whole numbers, you actually have to figure out what the different possibilities are. So instead of just greater than 80, we should go ahead and say 88 or more. And here we should go ahead and say 11 or more. Because you can't have 10 point anything, and you can't have 80 point whatever. So 88 or more. And we can fill that all in before we get started. So number one, and how many hardcover books did he buy? So that's the thing we're trying to find, and we don't care about anything else in the chart. Statement one, we just know that this was more than 150. If you divide that by 25, you get more than 6. For the same reason as before, more than 6 actually means 7 or more. And so this actually means 175 or more, because you can't have a decimal number of books. 175 or more. Definitely not going to be sufficient, because this can be anything in the world that's 7 or more. This could be 7 hardcover books, or it could be 700,000 million trillion hardcover books. So definitely lots of possibilities. So this is going to be at least. Thank you. It does say at least. So that was me not paying attention. So let's fix that. Thank you. This should be 150 or more. And so that's 6 or more. Still not sufficient for the same reason, because you have all of the possibilities in the world that are 6 or more books. So thanks for pointing that out. Statement 1 is not sufficient. Statement 2, the total cost of all the books was less than 260. So less than 260. Well, remember what our goal is. I mean, you could start doing inequality algebra, which we'll talk about in a second. But you could also just look for cases that do what you want. You could just look for different numbers of books that work. So here there's no minimum on the number of hardcovers. So it does say that Juan bought some books, so let's make it at least 1 or 2. But we could say like 2 of these, which would be $50. That's still way under 260. Or it could be 3 of these, $75, still way under 260. So this is insufficient. Again, remember the deal is to stay focused on the question. You don't have to go crazy manipulating algebraic statements if you just realize, oh, hey, I'm trying to show that we can have 2 numbers. If you can do that, just pick 2 numbers and make it work, then you can stay focused. So we need to combine the statements. That means we need to pull some of these data over to the next board. Let's pull the problem over there too. Okay, so here's the chart from statement 1, but we also need to incorporate statement 2 into it. So these need to be less than 260. How can we do this? How can we investigate? Chat box. What are we going to have to do? Yeah, we can't just do 150 plus 88 because that's just doing kind of random algebra, and it doesn't really take into account the fact that these are whole numbers. Well, okay, let's take a look at these and let's talk about this. Here's one student's comment. "150 plus 88 is less than 260. Does anybody have a response to that? Okay, so Shy T, you might want to check your arithmetic again because that's not true. 175 plus 88 is not less than 260. But just a second, I need about 10 seconds here, sorry. Okay, sorry about that. More technical issues here. Okay, let's take a look here. The first thing you want to realize is that this observation by itself, which I thought you were making this observation alone because nothing else showed up in the chat box for a while. But this is just one case that works, and that will always happen. So make sure you know this. This is one case that works. You'll always get at least one case that works because in data sufficiency you don't have things with no solution. The issue is there one solution or is there more than one? So the question is, and a lot of people don't take the time to sort out these basic issues, but the question here is, can we get more than one value for the number of hardcover books, which is the green box? Well, let's go ahead and take a look. So if it's 6, then we would have 6 or more hardcover books. So that means it's a total cost of 150 or more. And then the paperbacks definitely have to cost 88 or more. So the minimum is 150 plus 88. That works. That's only 238, which is less than 260. But the next value up is 7. If we try that, that's 175 plus 88. And that's actually 263, which is not less than 260. So there's actually, alternatively, if you don't want to do that arithmetic, the other thing you could do here is you could just look at this and say, I only have $22 left in my pocket. So in fact, I only have $21 left in my pocket because it has to be strictly less than 260. So that's not, I mean, instead of actually trying 7, you can also just look at it and say, I don't have enough money for another hardcover. So there's only one possibility for the number of hardcovers, and that's 6. So there must be 6 hardcover books. That's sufficient. So overall, this will give us an answer of C. Are there any questions? See, Sarah, you're typing stuff. So, okay. Let's talk about this real quick. This is a common problem that people have when they consider data sufficiency. So the question is, what if I realize that, so I'm going to shrink the problem up there so we can fit this onto the board. So the question that we're going to consider right now at the present moment is this. One of the students says, oh, only these two work, actually 7 and 12. So in other words, this student is pointing out that you actually can have two different numbers for that. Why is this not a problem? Like, why is this kind of thing not something that you actually have to think about or worry about? Anybody? Yeah, it's what Shy T wrote in the chat box. It's the focus of the question. I mean, one of the most important things that they're trying to do here is make sure that you can stay focused on the issue in the problem and not on other issues that don't matter. So, I mean, in fact, that's what they're testing here a lot more than they're testing actual math. Because this is not really a math problem. The only math that you have to do in this problem is add and subtract whole numbers, which is not usually a problem for people. So they're clearly testing you on another skill set here. And what that skill set is can you pay attention to what the question is actually about versus what the question is not about. So again, you have to stay focused on the information that you actually want. So the only information that we actually want is this green box in this chart here. We just care how many hardcovers. It's totally true that we don't know the number of paperbacks, and it could be 12 or it could be 11. But we don't care. Let's see. The next comment says this. So let's delete that last comment. If she bought 7 hardcovers and 12 paperbacks, the total is below $260. This is definitely not true. 7 hardcover books would cost $175, and 12 paperbacks would be $96. This is substantially greater than $260. Also, we know that that's greater than $260 because we can't even have 6. I mean, we can't even have 7 and 11. So make sure you consider other cases too. Like, we already got more than $260 with 7 and 11. So you should have rejected this conclusion anyway. I mean, this is also an important thing. Make sure you think about the results that you get. Like, we already derived down here the result that 7 hardcovers and 11 paperbacks is too much money. If you already know that and you're concluding that adding another paperback is going to cost you less money, then something is wrong with that. And I mean, if you're just pushing numbers around, you're not going to notice that. So make sure you're not just pushing numbers around. Make sure you're actually thinking about what they mean and what's going on in the problem and stuff like that. And finally, make sure you respect the things like simple arithmetic. So one of the things we can say the most here is that you got to give the so-called easy steps as much of respect as you got to give the hard steps. So, you know, you need to concentrate on easy stuff like simple arithmetic just as much as on harder stuff. Because, I mean, a mistake is a mistake is a mistake. And probably people screw up things more often when they just don't respect that step and don't think it's a challenge. Like, I would bet that people mess up math on these problems a lot more, arithmetic, a lot more than they mess up anything that's not arithmetic. So, it's kind of like the other one we saw where you just have to stay focused on the question. This is what they're really testing at the end of the day is, can you pay attention to what they want you to be paying attention to? And can you ignore what you need to ignore? So, any questions about this problem? Otherwise, we will try another one. Okay, let's try this one. Sorry, I may have been disconnected there. Please pick something. Remember, this is the GMAT. The GMAT is not a test where you are allowed to not pick answers. So if you are T-Money or URT or Emily, please pick something. Okay, here are statistics. If you still haven't answered the question, note that you are not really preparing yourself for the GMAT per se. Now, we got a totally even split here between C and E, so this is going to be interesting. Not a lot of A's, B's, and D's here, so we can probably get through the individual statements fairly quickly, but let's go ahead and do that. Remember, it's a yes-no question. So your goal here, as in other such questions, is to try to get a yes and a no. Let's see if we can do that. See if we can make that positive and then also make it not positive. So with statement 1, m minus 3z is greater than 0. One way to handle this is to add 3z to both sides. You don't have to do this, but having a difference greater than 0 is not as straightforward as when you move the other object over the other side. So one thing that should say plus 3z on both parts. You can get this as a takeaway from this particular part of the exercise. If you have a difference that's positive or negative, a difference meaning two numbers subtracted, it's positive or negative, then move one term over to the other side and make it not a difference anymore. So m is greater than 3z. So this doesn't really, because remember we need to think about signs here. So can we get a yes? Well, sure we can. Just pick two positives. Like for instance, m is 10 and z is 1. Can we get a no? Sure we can. Just pick two negatives. So like m is -1 and then z is -100 or something. So that's not sufficient. Again, notice how much it helps to be goal-oriented and to know what you are actually trying to do with these statements. It's very easy to get lost and not know what you're trying to do with the statements, but you got to know. My goal is to get a yes and to get a no. And as we said on the other slide, again, thinking about signs helps if you are stuck. A lot of these are about signs. If you're stuck, consider what signs might do in the problem. Statement 2 is really kind of the same thing. And we didn't even mark this up here. This is statement 1. Statement 2 is 4z minus m is greater than 0. Same sort of thing. It's a difference that's positive, so we should move a term over. So plus m, so 4z is greater than m. Same thing. Because if you've got 4z greater than m, that still leaves open the possibility that those things could be positive or could be negative. So as far as gridding goes, again, we've got A, D, B, C, E, but we've killed everything except C and E. All right, let's put them together. Well, how are we going to do that? So 2 statements together. So first, let's see if we can use them in their modified form, the form we made by moving the terms over to the other side. So we have one equation that says that m is greater than 3z. And we have another equation that says that 4z is greater than m. Does anybody know how we can combine those? There's a couple of ways. Yeah, one way that you can do that is to make a sandwich, which is kind of like just putting everything in order. What I mean by make a sandwich is that you wind up with 3 things in sort of a sandwich form, where the meat of the sandwich is the m, which is in both. Like you have your m, and then from the first one of those inequalities, we know that that's greater than 3z. But then from the other one, we know that it's also less than 4z. So what's the point here? Like when we do this, are we discovering anything that we don't already know? Aha. If you look at the bread of the sandwich, just the 4z and the 3z, we discover that 4z has to be bigger than 3z. The only z's that do that are positive numbers. So we've discovered that z is positive. But then we also know that m is sandwiched between 3 times a positive and 4 times a positive. So positive greater than m greater than other positive. So m is also positive. So this one's going to be sufficient together, giving us an overall C, but let's find a couple of other ways that we can deal with this. Another way we can deal with this is to add the inequalities. So remember, when you can add inequalities, you can add them when they have alligators that face the same way. So m is greater than 3z, and also 4z is greater than m. So you can add those, and that'll give you m plus 4z. is greater than m plus 3z. And if you subtract out as much stuff as you can, you get that z is greater than 0. And then once you discover that, you can go back to this fact, and you can discover that m is bigger than something that's positive. So m is also positive. One thing you cannot do is substitute. One person wrote this. This doesn't work with inequalities. Because what a substitution is something that's equal. So it doesn't really work to substitute with two inequalities. You can't substitute unless your substitution has to be an equation. Like the thing that generates the substitution should be an equation, not an inequality. Because you have to solve for something to be able to plug it in. So you can't really do substitution with two inequalities. So watch that. But another way you can do this with the two statements together is you can use the unmodified statements and you can just add them right off the top. So use the unmodified statements. So just take m minus 3z is greater than 0. And then take 4z minus m is greater than 0. And just add them and see what happens. So the m's go away in that case, and we have negative 3z plus 4z. And we just discovered this. And then we go back and use the fact that m is greater than 3z, so m is also positive. Still sufficient, still C. And then, because you guys probably like magic tricks, here's a fun magic trick that you can also do. You can do 5 times the first statement for no particular reason. That'll give you 5m minus 15z. You can do 4 times the second statement, which will give you 16z minus 4m. And if you add those, guess what happens? It actually gives you right away what you want. It gives you m plus z. It's kind of a cool magic trick. There's your rabbit from the hat. I mean, with the exception of this last magic trick thing, these are all things that you should be able to come up with. The magic trick is a magic trick for a reason. It's basically just entertainment. It's kind of neat. But did we do that in the other video, did we? Okay, maybe we did. So, but the point is that you can do any of these things at all. And so you can make a sandwich, you can add the modified inequalities, you can add the unmodified inequalities, or, you know, if you happen to have a hat with a rabbit in it next to you, you can do that too. What about this? Does anybody have any thoughts on that question? Because a lot of people spend a lot of time thinking about things like this. And to make the point a little more strongly, I'm going to change the word spend to the word waste. A lot of people waste a lot of time thinking about things like this. But yeah, exactly. Like the two responses that are up there. Pick your favorite or just go with what comes to mind first. Like, this is the way to think. Your goal is, so like during the test, you're not concerned with what's the fastest way to do this. You're just concerned with, I need to have a way come into my head and just do it. So shoot first, ask questions later. And then when you study, you're also not really worried about this. When you study, your goal should just be to learn as many ways as you can without bothering to make any judgments about faster, slower, easier, harder, because who cares? If something is a method that works, then it's a method that works. So when you study, your only goal should be learn as many ways as possible to solve the problems. Because faster and easier are irrelevant, because those are just on a problem-by-problem basis. And the fastest way to do one problem may be slower or maybe impossible the next problem. You just have no idea whatsoever. So this is not a good thing to think about. Because even if you have a way that you think is the fastest, if I have that way and I have another way, then I'm in a better situation than you are. So, yeah, the goal is just to learn as many ways as you can learn. Questions about this one? So we got a bunch of takeaways. The first is the usual thing about thinking about signs. If you're stuck, you can think about what signs do. If you have differences, you can move things over so they're not differences anymore. That's a takeaway. You can make sandwiches if you have the right kind of chain of inequalities. You can add inequalities together if they have the inequality sign facing the same way. You can't substitute. Remember, it's just as important to know what does not work as it is to know what works. And then finally, and most importantly, your goal here is just to learn as much stuff as you can. So it's not to try to rank things or to try to say this is better or this is worse. That's not the point. The point is just to learn a bunch of stuff. So let's try one more, and it's basically time, but because we had those technical difficulties earlier, I'm going to go ahead and extend the session by one problem here. So let's do that. Let's try this. Okay, guys, please try to pick one of the answer choices. Again, at the risk of redundancy, this is a test where you have to pick one of the answer choices every time. There's no thinking out on problems. So make sure you do that, please. Okay, so humble little problem here. If you are Anil or basically if you are Anil, please pick an answer because you don't have anything yet. Okay, Anil is going to sit this one out. All right, so this, there you go. Remember, Anil, if that's you, that was a long, long, long time. And you got to pick an answer before that. Okay, let's take a look. So, if x and y are integers and x is positive, is y Let me know if you guys can hear me. This technical stuff is starting to annoy me. Okay, you can hear me. That's good. You can take 7x is greater than 0, and you can... Sorry about all these technical difficulties. The internet's being not great right now. You can add 2y to both sides. that gives you 7x is greater than 2y. So that's a little bit more helpful. So we know that this is positive. So the problem is that being positive being greater than something doesn't really help. So we know that this is less than a positive number, and that's all we know about it. So I'm typing on the board, yeah. You don't see me typing on the board. Oh, that's so bizarre. Let me try to I might have to try to quit out of the session again, as annoying as this is. Because I am writing on the board, but I see that apparently isn't registering, and that's especially strange because it thinks that I'm here. That's interesting. Okay, I'm going to go ahead and quit out and try to rejoin. Okay, I'm back. Now I have to wait for all of these screens to load up again, but I think this should work. We're basically about finished here anyway, but I gotta wait till these graphics load on my end, and then I can start typing. Okay, so here is what we have in statement 1. This is a difference. So yeah, you guys really got nothing on the board. Okay, that's a difference. When you have a difference in an inequality, as we noted last time, you can move one term over to the other side. And that will make something that's a little bit more instructive to think about in terms of signs. So 7x is greater than 2y. The problem is this is a positive number. We know that from the problem statement. So all we know about this is that it's less than a positive number. Less than a positive number doesn't really help. That could be anything. This could be positive, negative, or 0. So not sufficient. Statement 2 says negative y is less than x. So again, x is positive. That doesn't really help us. Negative y is something less than a positive number. So this doesn't help either. So we're going to need to combine these things. Does anybody have any insights as to how we're going to do that? In the chat box. So we can try to add the equations, we can try to flip stuff, we can try some things. Let's just try stuff. So again, let's just see what happens. So the two statements together are 7x greater than 2y and x greater than negative y. Let's make them face the same way. So one way we can do this is to try multiplying. I mean, multiplying by 7 is a little bit icky, but we can multiply by 2 instead. So we can, on the bottom equation, keep the numbers more manageable. So if we add together this inequality and this inequality, that's just going to tell us that x is positive. It's going to tell us that 9x is greater than 0. But we already know this. So again, what we're doing though is we're just trying stuff. We don't want to try to premeditate too much here. This turns out to be a dead end. You also can't substitute. We also can't combine observations about signs, because this is about as good as we're going to get with that. So what can we do? Like, how do you actually prove insufficient? Like, what's the only way to conclusively prove insufficient? Yeah, you gotta pick numbers. Like, a lot of people are just focused on nothing but algebra here. The problem with statements that are insufficient is what insufficient means is that the algebra doesn't work. And so if the algebra doesn't work, then you're not really going to be able to show that by doing algebra. So you have to have number testing as a primary thing in your head. This is just as important as algebra. And if your head doesn't think about it that way, you're at a severe disadvantage on these problems. Like, you must prioritize number testing as highly as algebra. Because, I mean, that's the only way you can prove that something is insufficient. If we try algebra on this problem, what's going to happen is we're just going to keep groping around in the dark, and things are just going to magically not work, and we're just going to be sort of frustrated. But let's see if we can prove insufficient. Well, 7x is greater than 2y. So let's just let x be some random positive number, like 5. So this equation gives us 35 is greater than 2y. And this equation gives us 10 is greater than negative 2y. So this means that y is something less than 17.5 up here. And this means that y is 5 is less than negative y. Divide by negative 1, that turns the inequality around. So if you pick numbers, you can show explicitly that this is still insufficient. If x is 5, then you can get y's that are positive. So y is 1, 2, 3, etc., up to 17. Those give you yes answers. But by the same token, if y is negative 1, negative 2, negative 3, or negative 4, those are no answers. So still insufficient. And that's going to give you an answer of E for elephant here. So a lot of people may be surprised because there's a lot of people who picked C for this one, but turns out it's not. Okay. Any questions? Satish, you can do that, but just because you add up things in one way doesn't mean that it's totally insufficient. Because you might still have some other way to combine the equations. Like if I had a few minutes, I could make up a situation where that would work. Like in fact, the last problem that we saw is like that. If you just add these, then you're just going to think that M is positive, or sorry, you're just going to think that Z is positive, and you might forget that you know anything about M. So same sort of thing here. You can't just add the equations and look at what you get. You actually have to use the collective of all the information in the problem. In some cases, if you just combine them and just look at the combined version, then you'll get the whole thing incorrect. So you got to be careful there. Okay, other questions? We're going to wrap this up pretty soon. Again, apologies for all the technical difficulties that have persisted through this particular session. But thanks for attending. Hope it was still fun, valuable, all those things. And thanks for being patient with all the disruptions. If you have any quick questions, go ahead and fire away. If you have any admin questions or questions about business-related stuff with MGMAT, go ahead and fire away. Otherwise, we will quit it here in a second. Okay, Sarah, let's see, I'm going to go ahead and kill the recording.